The Solar System, comprising the Sun and the myriad objects gravitationally bound to it, is a fascinating subject of study in the fields of astronomy and planetary science. This complex system includes planets, moons, asteroids, comets, and other celestial bodies, all of which originated from a common source and have evolved over billions of years. This comprehensive video will explore the processes and stages involved in the formation and evolution of the Solar System. Before starting, don't forget to like and subscribe to our channel for more future updates. Formation of the Solar System. The Solar Nebula Hypothesis, the widely accepted model for the formation of the Solar System, is the Solar Nebula Hypothesis. According to this hypothesis, the Solar System formed about 4.6 billion years ago from the gravitational collapse of a region within a large molecular cloud. This region, known as the Solar Nebula, was composed primarily of hydrogen and helium, along with heavier elements produced by earlier generations of stars. Collapse of the nebula. The collapse of the solar nebula was likely triggered by a nearby supernova explosion or other perturbations. As the nebula collapsed under its own gravity, it began to spin faster due to the conservation of angular momentum. This increase in rotation caused the nebula to flatten into a disk shape with the proto-Sun forming at the center. Formation of the Sun. As the density and pressure at the center of the collapsing nebula increased, nuclear fusion reactions ignited, leading to the birth of the Sun. The Sun formed from the central bulge of the nebula, where the majority of the mass accumulated. The heat from these reactions created a protostar, which eventually became the Sun we know today. Formation of planets. Accretion of planetary bodies surrounding the proto-Sun was a rotating disk of gas and dust, known as the protoplanetary disk. Within this disk, dust grains began to stick together through electrostatic forces, forming small clumps. These clumps collided and merged to form larger bodies called planetesimals. Over time, planetesimals accumulated more material through gravitational attraction, growing into protoplanets. Differentiation of terrestrial and Jovian planets. The planets in the Solar System can be broadly classified into two categories: terrestrial, rocky, planets, and Jovian, gas giant, planets. The terrestrial planets, Mercury, Venus, Earth, and Mars, formed closer to the Sun, where temperatures were high enough to prevent volatile compounds like water and methane from condensing. These planets are composed primarily of silicate rocks and metals. In contrast, the Jovian planets, Jupiter, Saturn, Uranus, and Neptune, formed further from the Sun, where temperatures were low enough for volatile compounds to condense into ices. These planets began as rocky or icy cores that captured massive envelopes of hydrogen and helium gas from the surrounding nebula, growing to immense sizes. Evolution of the Solar System. Clearing the protoplanetary disk. As the Sun reached its main sequence phase, it emitted a strong solar wind that swept away the remaining gas and dust in the protoplanetary disk. This process, known as disk clearing, marked the end of the primary accretion phase of planet formation. The remaining planetesimals and protoplanets continued to collide and merge, eventually forming the planets and other small bodies in the Solar System. Heavy bombardment period. During the early history of the Solar System, the planets and moons experienced a period of intense meteorite impacts known as the Late Heavy Bombardment. This period, which occurred around 4.1 to 3.8 billion years ago, is evidenced by the numerous craters observed on the Moon, Mercury, and other bodies. These impacts played a significant role in shaping the surfaces and compositions of the planets and moons. Small bodies in the Solar System. Asteroids and the asteroid belt. The asteroid belt, located between the orbits of Mars and Jupiter, is a region populated by numerous rocky bodies. These asteroids are remnants from the early Solar System that never coalesced into a planet, likely due to the gravitational influence of Jupiter. The largest asteroid, Ceres, is also classified as a dwarf planet and has a differentiated interior, suggesting a complex geological history. Comets and the Kuiper Belt. Comets are icy bodies that originate from the outer regions of the Solar System. They are primarily found in the Kuiper Belt, a region beyond the orbit of Neptune, and the Oort cloud, a distant spherical shell surrounding the Solar System. When comets approach the Sun, their ices vaporize, creating glowing comas and tails that are visible from Earth. The Kuiper Belt is home to many dwarf planets, including Pluto, which was reclassified from a planet to a dwarf planet in 2006. These distant objects provide valuable clues about the early Solar System and the processes that led to its formation. Evolutionary milestones and future prospects. The role of impacts and catastrophes throughout its history. The Solar System has been shaped by numerous impacts and catastrophic events. These include the giant impact that formed the Moon, the Late Heavy Bombardment, and impacts that have caused mass extinctions on Earth. Such events have played significant roles in shaping the geological and biological evolution of planets and moons. The future of the Solar System. Looking to the future, the evolution of the Solar System will continue to be driven by gravitational interactions, stellar evolution, and other dynamic processes. In about 5 billion years, the Sun will exhaust its nuclear fuel and enter the red giant phase, expanding and potentially engulfing the inner planets, including Earth. Eventually, the Sun will shed its outer layers, leaving behind a white dwarf surrounded by a planetary nebula. The orbits of the planets will continue to evolve over billions of years, potentially leading to close encounters or collisions. Small bodies like asteroids and comets will continue to interact with planets, occasionally leading to impacts. Human exploration and understanding. Early observations and theories. Human understanding of the Solar System has evolved significantly over millennia. Ancient astronomers, such as those in Mesopotamia, Greece, and China, made early observations of celestial bodies and developed geocentric models of the universe. The heliocentric model, proposed by Nicolaus Copernicus in the 16th century, revolutionized our understanding by placing the Sun at the center of the Solar System. The space age and modern discoveries. The advent of the space age in the mid-20th century brought about unprecedented exploration and discoveries. The launch of spacecraft such as the Voyager probes, the Hubble Space Telescope, and numerous missions to the Moon, Mars, and beyond has provided detailed data about the Solar System's composition, structure, and history. Modern telescopes and space missions continue to expand our knowledge. For instance, the discovery of exoplanets around other stars has provided insights into the diversity of planetary systems and the potential for habitable worlds beyond our own. The search for life. One of the most profound questions in the study of the Solar System is the search for extraterrestrial life. Missions to Mars, such as the Perseverance rover, aim to uncover signs of past or present microbial life. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, with their subsurface oceans, are prime targets for future missions seeking to detect life. Conclusion. The formation and evolution of the Solar System is a story of dynamic processes and interactions that have shaped its current state. From the initial collapse of the solar nebula to the ongoing geological and atmospheric changes on planets and moons, the Solar System is a testament to the complexity and wonder of the cosmos. As human exploration and scientific inquiry continue, our understanding of this intricate system will undoubtedly deepen, revealing new insights and mysteries about our place in the universe. This is it for today's video. What do you think of our video? Comment below with your thoughts and let us know. Don't forget to like and subscribe to our channel for more future updates. Thanks for watching.